So today we will discuss the AND-SIM solution. Question one is write an algorithm for evaluating the polynomial using brute force method, iterative approach. Improve it using a recursive approach, and compare the performance of both versions. So the algorithm for brute force technique is function evaluate polynomial iterative coefficients are and the parameters are x, so coefficients and x, and the bracket we have to write let result is equal to 0, set as 0, and for loop as bracket, and in the bracket the condition is let I is equal to initialize the I from 0, and the condition is I is less than coefficients dot length and I plus plus, that is, and then the code in the body of the for loop, that is result plus is equal to coefficients of I into math dot pov x I x comma I. Algorithm for recursive relation. Function evaluate polynomial recursive, and then in the bracket the parameters are coefficients x and degree. If degree is equal to 0, then we have to return the coefficients x 0. Else we have to return the coefficients of degree of x into math.pov pow x degree plus evaluate the polynomial, and this. Question number 2 is write a program and draw the flowchart or program algorithm for finding the root of the given quadratic equation, all possible input conditions and scenarios. So program for finding roots, that is we are using JavaScript. So functions finding root ABC, ABC are the parameters, and then const discriminant is equal to b into b minus 4 into a into c, and if discriminant is less than 0, then we have to write const root 1 is equal to minus b plus match dot sqrt discriminant, and then we have to divide it from 2 into a. And similarly with constant root 2 is equal to in the bracket minus b minus math dot sqrt discriminant divided by 2 into a. Then we have to return the roots root 1 and root 2. Else if the discriminant is equal to 0, then const root is equal to minus b divided by 2 into a, and then we have to return the roots. Else return. Question number 3 is write an algorithm for or program or draw a flowchart for finding cube root of any given positive using the inbuilt function. Algorithm for finding roots are from by using Newton's Raphson method, that is function cube root x in the bracket let guess is equal to x divided by 3. This is the initial guess. And while maths.abs in the bracket guess into guess into guess minus x, then if it is less than 0.001, then we have to continue it loop. This is loop. Then the body of the while loop is guess is equal to in the bracket 2 into guess plus x divided by guess into x divided by 3, and this is the Newton's method, and that's it. Question number 4 is write an algorithm or program and provides flowchart for finding roots of the equation x into x minus 1 is equal to 0 using the point iteration method. So algorithm for point iteration method is function point iteration method in the bracket. The parameters are x0, comma tolerant, let x equal to x0, let iteration is equal to 0, do x0 is equal to x equal to maths sqrt in the bracket 1 plus x0 iteration, while math dot abs x minus x0 tolerance, then we have to return a root is equal to x iteration. Question number 5 is write an algorithm for Gauss-Gordon iterative method and compare its performance with elimination method. So the Gauss elimination method iterative method is this is the iterative method, and the comparison performance comparison is the Gauss-Jordan iterative method is more computationally expensive but can yield more accurate results compared to Gauss elimination method. And the four disadvantages, right? The four disadvantages of Gauss elimination method and three advantages of Gauss Seidel method. So disadvantage of Gauss elimination method is requires additional storage for the augmented matrix, may lead to numerical instability for ill-conditioned matrices, not suitable for sparse matrices due to large number of operations. Pivoting may be necessary, adding computational overhead, and the advantages are of Gauss Seidel method are memory efficient as it As it updates the solution iteratively, converges faster for diagonally dominant or symmetric positive definite matrix well suited for parallel computation. Question 7 is right algorithm for predictor corrector method. Algorithm for predictor corrector method is function predictor corrector method, and the implementation of method is then we to apply the method. This is the syntax, and then obtain the Simpson's 3-by-8 rule from Newton's code formula. Simpson's 3-by-8 rule is derived from Newton's code formula by integrating the we have to integrate the function from three equally spaced points. The formula can be expressed as int a to the power b fx approx frac 3h into 8 in the bracket x f of x underscore 0 plus 3 f x underscore 1 plus 3 f x underscore 2 plus f 3x minus 3 underscore 3, and then where h is the spacing between the points x0 x underscore 0 x underscore 1 x underscore 2 and x underscore 3 and are equally spaced points intervals. So this is the solution for NSM.